This is the presentation of the Fort Wayne train automated controller. You launch the controller by double-clicking ctc-ui.jar or by running it from a command prompt with the java jar command. Notice the first thing that opens is the track model. This is the building block of our track, and everything else in our modules corresponds to the track itself. As such, it is launched first. This is the CTC. From here, an operator is able to view the schedule, change modes, dispatch trains, dispatch maintenance blocks, and test switches. In addition, this map will output the current position of any trains, as well as trains shown here and here. For the purpose of this demonstration, the red line is not implemented. You can adjust the timescale by entering a number. Entering a non-integer number will not go through. It will not break the program. We'll now go to the MBO for scheduling.
When the MBO is first started up, it will not initially have drivers or throughput set for each line. This will be set by the planner. The planner may input throughput, which we will set as 1,000 for each line for the sake of this demonstration, and may choose to add drivers by hand or through a file. We will add them through a file. The drivers are displayed here. Times marked with true mark a place where the driver has said they are willing to begin a shift. This will commit them to a full 8.5-hour shift after the start of this time. Upon returning to the main MBO, you can now hit Generate New Schedule, and a schedule will be generated based off the current throughputs that have been set and based off the driver's schedule. This schedule is saved to a resources folder, which can be accessed by the CTC to be loaded into the CTC.
Loading the schedule from the CTC is a relatively simple process. You open the scheduling pane. You may either select a date or browse. For the purposes of this, we'll use the browse function. These are a variety of schedules. This is the one that has just been generated. You will see that the green line is outlined in green and the red in red with differing colors in order to show different blocks of time. In addition, the date is now displayed here.
When we get to the track controller, the first thing we'll do is load a PLC program. The program that I'll load is displayed right here. We go through a file browser to find the PLC file, and this one's for the green line. This PLC program contains Boolean logic statements which will set the proper switch positions according to the occupancy on the track. We'll now switch into run mode, assuming the program has been validated. You may only switch into run mode if the occupancy on the track is 0. The track is empty. Now that we're in run mode, we go to the track model.
Here you can see the track model. It is of course, model of the entire track, green line, red line. Displays most of the same things that the CTC and others that use it do, such as the track occupancy. However, since this is the central model, it also has information about things such as the railroad crossings, which are displayed here in these little green lines, which turn red whenever the crossings are active, and the switches, which are these little dots at intersection that will turn blue whenever the switch is in the alternate position. In addition to showing the track, if you open this down here, you can see more in-depth properties for each of the track, such as the physical block properties, such as length, speed, grade, elevation, and stuff like that, as well as things that happen whenever the simulation is running, such as the speed limit and the authority that is received from the CTC sent through the track controller. We also have a few things that you can change here, such as turning on and off the track heaters. As you can see, this persists, you turn on and off. However, nothing else can actually be edited during runtime. You can also apply errors to different points on the map. As you can see right here, we are in A3, which is somewhere around here. So let's apply a circuit failure. You can see on the map that it has been marked as unavailable, and this has been propagated up to the CTC so that no trains will be allowed to go there. And you can just simply clear these errors. As you can see, it worked in the CTC too, and keep going.
We will now dispatch a train to block L73 Dormant Station. We enter the ID of the train, then select a section, then select the desired block. You enter the speed in miles per hour. Or enter it 20 miles an hour. The arrival time is 3:22 a.m. It is on the green line. Click dispatch. It will launch the train process, which brings up the train model and the train controller.
So here in the train model GUI, you can see valuable information like the velocity, current velocity in miles per hour, the acceleration, received power command, the force acting on the train, as well as some of the physical properties like the current cabin temperature, number of cars, and the train's current weight. Looking at the train controller, there are also a bunch of unpopulated variables here. That is because KI and KP have not been set yet. If they are not set, or the values are invalid, you hit confirm, automatic ones will be set. So that's what we'll go ahead and do. And so now the train has begun moving after those values have been set. It's in automatic mode right now. You can move it to manual mode. You can hit the brake real quick. And you can see that it slows down and sets power command to 0 temporarily. Authority is 1, which means it has the authority to move. If I move to cabin, I can toggle the lights off and on. I can also try to open up the doors to no avail because the train is moving. And that's about it for the train controller right now until it reaches its destination.
We will now up the time scale to 3 times in order to accelerate the train's travel to its destination.
As you can see, the track controller updates occupancy as the train moves down the track. This will also update the switch positions and crossings.
As you can see, the train controller has successfully moved down the track, and you can't see it very well because the cabin is not illuminated, but the right doors did open automatically to facilitate Dormant Station. You can also open and close those doors appropriately. And another thing to show off is the temperature. You can set it to 75 and it'll be valid, but if you try to set it to something too high or something too low, you will receive error messages, and it will also set the temperature back to what it was originally.
We will now dispatch a train in MBO mode. Simply select MBO and hit confirm to enter the moving block overlay mode. Then send train 1 to section L73 Dormant Station at 20 miles an hour. It generates the arrival time as before.
With the train launched in NBO mode, the NBO now is able to keep track of the train's GPS position. Using this GPS position, it determines the train's block location. Based off the train's speed, it calculates the safe stopping distance in yards. It assumes a constant negative deceleration of 1.2 meters per second squared from the brakes. The authority will be set to true if there is nothing in front of it, which there currently is not. And suggested speed is not currently working. though hopefully it will be up by the presentation tomorrow.